Hello, welcome to educator.com. Today's class is an overview of intermediate C++. You should have taken the introductory class before if you have had no prior programming experience, but we will be assuming some experience here, but hopefully we'll learn a lot and we'll have some fun along the way. Okay, we're going to start. We will have a bit of a review of what's going on with C++. The class will cover things like containers. In particular, we'll have the vector, list, set, and map type containers. Now, if you're coming from another language like Java or something like that, then you already are familiar with the concept of lists and sets and things. Otherwise, but don't worry about it. We'll cover it all. We will cover templates in C++. You have to cover object-oriented programming. It's just something you just have to do for C++. That's the whole reason to do C++ versus C, is to get the object-oriented techniques involved. We will do some operator overloading that some other languages cannot do, but it's one of the things I think is very powerful in C++ that allows you to express your expression, your language constructs in a more compact, user-friendly sort of way. Everybody knows that A equals B plus C. Everybody knows what the plus does. Everybody knows what the equals does. You don't have to write out some verbose things. So when you create a brand new object, you define your own plus sign operator for that object that works the way plus works. We'll do some exception handling. Unfortunately, things do not always go as planned, and so you need to be able to throw exceptions and catch them. So when something goes wrong, you can handle that exception based on which exception gets caught. And we'll take a quick look at namespaces so that you avoid namespace collisions. Input and output. Now, in the introductory class, we did cover some input and output. This class will get a little bit more detail, a little bit more behind the scenes types of stuff of how the objects are organized with each other, some of the bit flags that are available to be manipulated. We will talk a little bit more about some functions, some function features that we didn't talk about in the first class, some more types. Preprocessor macros is a very powerful, very dangerous feature in C++. There's a lot of things that you can replace it with C++ language features so that you make things much more safer. But there's other things that you don't have any other choice. The best way to do it is with a preprocessor macro. So we'll talk about all of that, and we'll talk about compiler options, how to put all the code together and then flip a flag on the compilers that when you compile the code, you get different features, different sections of code, etc., etc. Now, this is not a class for a neophyte. If you're coming in and you have no programming experience, you don't know Pascal, you don't know Java, you don't know BASIC or anything else, you probably want to take a look at the introductory class. So we do expect you to have some programming knowledge. Take the introductory class if you've never programmed before. It's not that bad. It's a lot of fun. It's very useful, but we are expecting some knowledge. So we will overview some language features that you're expected to be already familiar with. We'll run a quick overview. So if you're not sure whether you know enough, we'll just take a look at the overview. If it looks familiar, then you're good to go. If it looks strange, you say, what is he talking about? Well, maybe you want to go take the intro class first. So we'll be talking about data types, operators, expressions, variables. We'll be branching, looping, some arrays, some pointers. We'll deal with functions, object-oriented, of course, and some input-output. Now later we'll introduce some useful features that were not covered at all in the intro class, and we'll cover some familiar territory a little bit more deeply. So we'll have some discussion of each feature. We'll talk about the pros, why you want to use this feature versus some other feature, some cons, and some caution. This is a very good feature to use, but be careful, and we'll talk about all of those. So containers, the vector container, very powerful feature in C++. It includes both templates and containers. We'll be looking at the container part of it first, and then later we'll talk about templates. But you don't really need to know a whole lot about templates in order to make use of the vector. So the containers are implemented using the templates. Yeah, the vector is first because it's the classic first thing that everybody wants. Everybody asks for an array that can be any size that they want it to be. He says, I don't know, why should I set it up to 300? If 300 is too much, I've wasted a lot of memory. If 300 is not enough, then the system will crash when we get to 301. Well, use a vector. It's the first one to learn typically. It solves that basic problem, the dynamic array. So here's a static array. We'll set up the integer. The maximum number is 300. We'll have an array of floating numbers. What if I have 310 numbers? That's 10 I can't put in there. Our solution, use the vector. So instead of a floating array of numbers with a concrete maximum, we have a floating vector of numbers, and that grows as needed. You can start it at 300. You add one more. It says, okay, we need more space. It will allocate more space. It will grow until the system runs out of memory. So if your number size is too large, you just resize the vector. If you use the pushback method, let me erase this, do this right. If you have numbers, if you just add it using pushback, and you put in your new number, so you've got 0, put it in, you'll become 1, you put it, keep pushing, it comes 2, 3, 4, you get up to 300. If it's allocated to have 300 slots, you do one more pushback, it will automatically allocate more memory to make room for the new slot. And we'll look at the linked list as another type of container. Linked list is one of the most basic data structures that's covered in a computer science class. Almost every computer class in the world covers the theory of linked lists. This class is not one of those. We figure you know what a linked list is and how to use it. We'll show you how to use it using the standard library vector or template. Vector is the other type of template. So this class shows how to use the standard library list container. And we'll let others do the heavy lifting. So someone has done all the programming work to handle adding a new linked list, inserting into a linked list, allocating more memory for a linked list, deallocating. All that has been done. All you need to do is use it. Here is an example traversal. We'll define our list, a list of doubles. Now this can be any object. If you define your own object in the object-oriented section of the class, which we'll pick up, you can put that here instead of double. So we'll have an iterator, which is defined as IT, and we'll get begin, which is a method which returns the first node, the first element of the list in the list container. So we'll have our while loop. While we're not equal to the end, we'll keep processing in this loop. So here, the processing just matters, we just print it out. And we dereference the pointer. Iterators act like pointers. And then we advance to the next node in the linked list. So this will continue until it gets to the end. Now, we have additional containers. We have the set and the map, and I talk about them together because they're very similar. It's another classic data structure learned in most computer classes called the binary tree, which allows you to do a very rapid search for something. If you have an array is full of numbers or full of keys, full of data, and you're looking for specific data, you have to start at the beginning and keep looking and looking and looking and looking until you get to the end. That can be very time consuming. With a binary tree, you start at the top. If it's less than, you go this way. If it's greater than, you go that way. And you do this recursively until you find your data. It tends to be very, very fast. Of course, you pay for this with extra memory because you need memory for the pointers. But most of the time, speed is more important than space. So we're not going to actually build binary trees ourselves, just like linked lists. We're not going to cover the theory of how they're built very much. We're just going to talk about how to use the container in the C++ standard library. So we'll be talking about set and map. And again, they're not sequential containers the way linked lists and vectors are. They're retrieved in a certain order in only the fact that they're kept in that order used by virtue of the binary tree. Now a set retrieves a unique key. It will, for the most part, keep the keys unique. If you try to put in something that's already in there, it will throw back an exception or it'll give you some type of an error message depending on how you have it configured. A map retrieves the unique key and it retrieves a value related to that key. So it tends to be a little bit more useful in terms of you have what other languages call an associative array. So you don't have to have, like here's our example here. We'll have a map and we have to give it two types. We're going to have a string as our key and string as our value. And we're going to call it properties. It's like a properties list. If you're familiar with Java, you've seen properties, the properties type. So we'll have properties user and we'll set that equal to Alvin. So now later on in the code, you can print out or you can process or you can log in as grab the properties Alvin. Or grab the properties user, which is, in this case, Alvin. So if the properties password is equal to 12345, you can print out that's a dumb password, change it now. Now templates in C++ is a very powerful language feature that has recently been adopted by a more famous and younger cousin whose name will not be mentioned herein. It allows for code reuse and modularity without forcing the system to be object-oriented. Object-oriented is it's a powerful technique for programming, but there are many cases where it is not the best way to go. So with a template, you can move your emphasis to algorithm instead of trying to cram everything into an object. Now, we still have some cautions to deal with in templates, but we will talk about those in the lesson on templates. Here's a classic example. We want to swap two variables. Now, in swapping two variables, you have A and B that are equal to something, and you want to swap them. You can't just say A equals B, B equals A, because when you say A equals B, now the previous value of A is lost. So you have to have a temporary variable. Now, if you'd have to do this in a lot of different places, you've got an integer function. This is an integer type will be swapped. A string type will be swapped. Well, we'll make a template. So we'll have, and by the way, I called this swap too because there was already a swap template in the library. So here's how we define it. We say this is a template. We'll be using type name capital T, which is a type that is a whole placeholder for when we actually give it a real type. So void is our return type. We're not going to have a return type. So here's a reference to the left-hand side of that type, a reference to the right-hand side of that type. Here's our temporary variable, which will be initialized. This is called temp. It's initialized to the left-hand side. So now that we've saved the left-hand side, we can override it with the right-hand side and then set the right-hand side equal to the left-hand side. So we have a couple of tests here. We have int equals A, B equals 20. A equals 10, B equals 20. So we swap these two variables using the integer version of the function. We swap A and B, so now B is now 10, and A is now 20. You can do the same thing with string. If we have string X equals some text, and string Y is equal to some text, we can run swap2 on string. against X and Y. So the code is already written. So basically, we don't have to worry about the string object or the integer object. Basically, we have an algorithm. This is how we process this data. And you just give me what the type is. As long as the type is compatible with the algorithm, it will work, and you won't have to rewrite this for every type that you need to work with. And of course, object-oriented programming is a very powerful feature, programming technique. Many languages have this now. It's generally called OOP, O-O-P. There's also OOD, O-O-D, for object-oriented design, object-oriented analysis. Now, critics of C++ have said that it's only grafted onto the C language. So they leave intact most of C's original non-features. Many of us don't call that a bug. We say that's a feature. We like the fact that if we need object-oriented programming, it's there, we can use it. If we don't need it, we don't have to use it. So that's one of the strengths of C++ as compared to a lot of other languages where everything is forced into being an object, even things that really should not be considered an object. So we'll discuss how classes and objects are created and instantiate variables from the objects and classes. We'll discuss the different constructors, how to do a deep copy. Sometimes you have members inside the object, and those members have to call their constructors their copies. We'll discuss the difference between an is a relationship and a has a relationship. And of course, destructors, if you allocate any memory in your constructor, you have to get rid of it. Because unlike some languages, there's no automatic garbage collection. You, the programmer, are in charge of allocating memory and then giving it back to the system when you're finished with it. And we'll talk about multiple inheritance, which is another feature that's relatively unique to C++. There's not many languages allow you to inherit from more than one superclass. And how to design a class for inheritance. If you could design a class, and if you don't keep in mind that it might get inherited into another class, that inheriting may not work very well. So it's part of your design. You decide that this class will be derived into that class, and so this class will have certain features and certain keywords. Because you can't just say, well, oh, gee, there's a great class over there. We'll just inherit from that class. Well, no, that class may not have been designed to be inherited, so inheriting from it may not work very well. And we'll talk about a OOP breaking system called a friend, where you declare this particular function as a friend, and that function now has access to all your internal private members that are ordinarily kept away from objects outside of your object. But C++ has a friend, and there's a few places where it's extremely useful to, especially with operator overloading, where you can decide, well, this particular function, because we're going to write it ourselves and we're going to put it here, and it will have access to the insides of this object. The operator overloading is a very powerful part of object-oriented programming in C++. You can write your own polymorphic functions for the standard set of operators. The operators that everybody is used to using for the specific types of things that they do. Now, it's already pretty much a standard feature in almost every programming language. It's just you can't create your own. As an example, if you see this text here, A equals B plus C, you know what it's supposed to do. The variables could be integers, they could be floats, they could be strings. You could have written some other things that are using it. But, you know that it's going to assign the result of the addition between those two different things. And based on what the types are, the plus sign, for example, will do something different. So like if you have 3 as an integer plus 5 as an integer, a certain code will operate. It's a certain function. If you have 3.7 adding to 5, now you've got a float on one side, you've got an integer on the other side, you've got a certain different operation to do. So operators are already overloaded. It's just the difference with C++ is, hey, we've just created an object. We want to be able to add them together because this is a mathematical object, and adding this mathematical object to this mathematical object makes sense. Let's add them together and use the plus sign. So in C++, there could also be instances of a custom class that you wrote, and you overloaded the plus sign operator. So here's an example where we're overloading the assignment operator. So we have my class is the class, and that's the type of the right hand. This is a reference. And so we have code that copies the member values in the right-hand side class and copies them each to the member values of the class who owns this operator equals function. So the equals is overloaded that way. It's very simple, and the number of details to keep in line, but after when the details are all in line, everything works very well. And exceptions. Practical programming means you handle unexpected conditions. Probably between two-thirds and 9/10 of your programming is going to be, what do I do if this didn't work? I'm going to write some data to a disk. What do I do if the disk has crashed and I get an error back? I need to ask the user for an input. I need for him to send me a number, 11. What do I do if he types out ELEVEN instead of giving me the 2 digits 1? So there's a lot of programming is not just doing the programming. It's handling the conditions that are not correct. So your computer should not crash just because the printer stops working. So you get an exception back. It says, hey, I'm not getting any answer back from the printer. Okay, well, we'll do something about it. So at the same time, your application shouldn't crash because the user didn't type something right. So yeah, ask him for a number. He types in 11, ELEVEN, and your computer system just takes it. Can't parse it, so it puts a 0 in there, and now all the answers are wrong. No, you test the user input. If you can't parse it, then you put a prompt back. Says, I'm sorry, I can't answer that. So there have historically been different ways of passing along information, because you have a function that calls a function that calls a function that calls a function. That function says, I got a problem. I can't handle this. So it has a return code back, it has a return code back, it has a return code back, and someone says, oh, well, we'll have to do something about this. So that's your return value on your function calls. Or sometimes you can have an output parameter on your function command list. So you call a function, you call the function, and you want the return value, you want to use the return value. So what do we do to find out something went wrong? Well, we'll have a output parameter. So after you get your return value, you test the output parameter. If it says good, you keep on processing. And of course, there's also a deliberate crash. So we just found a condition that's so horrible, there's nothing that we can do for it that won't make it worse, so we'll just stop running. We'll create a core dump, and the user can look at the core dump and analyze what went wrong. But with an exception, you can throw an exception, and anybody who doesn't need to handle the exception doesn't need to look at it, because it'll automatically kick itself up each function call until it gets to somebody who's handling that particular exception. So C++, modern languages allow code to throw and catch exceptions, and C++ is no exception to that rule. So the way C++ exceptions work, it throws a type, and the type can be like an integer, which can be a value like 1 or 2 or 3. And when you handle the exception, you catch that type. So you have a handler that says catch an integer, and then you'll get a variable, and you test that variable. If it's equal to 1, that means the exception is this. If it's equal to 2, that means the exception is that. You can also define an exception object and capture that as the type. So here's an example. We have integer divide, int a divide by int b. You can't do divide by 0, so we do a test. If b is equal to 0, we'll throw an exception. So what we'll be throwing is the integer 10. So the other function that calls it, we have our try-catch block. So x is dividing 10 by q. We don't know what q is because that was passed to us by our caller. And if we get an exception, that'll be passed into e. We can say if e is equal to 10, then we'll print out we have a divide by 0 error, or we can throw our own exception so that our caller has to deal with it. Or we can just ignore it, and the exception will automatically go up to whoever called our function. Now, namespaces is handled in C++ with a namespace keyword. Any sizable project will incorporate code from various different sources, and there's a huge risk that everybody will use the same name for one key function, and it will result in name collision. For example, one vendor has his own date class. Now, we've already got a date class that we've been using for a long time that we like, and anytime we want to change it, we just go in and change it, but it happens to have the same name, date. What do? Well, you can say, well, we're not going to use that vendor's code. Well, that vendor has got code that we find very useful. It does what we need, and it just so happens his code calls their version of date, and their version of date has got the same name as our version of date. Well, their version of code should be in their own namespace, and our version will be in our different namespace. So, like we'll have my company com, and everything within there, all these objects will be in that namespace. So that's where we can have our definition for date, and that way we don't have to worry about the name collision. And we can even put a little alias here. We call it ours because we don't want to have to type my company com. But the reason why we have my company com is that's following the internet protocol for doing a website. You'll have mycompany.com, and the companies that handle putting out internet domain names already guaranteed that will be unique. So just use that, and you're guaranteed that namespace will be unique worldwide. So we just have this alias here because we don't want to have to type that all out each time. So our date is equal to our current date. When we're calling the vendor, we'll use their namespace to call whatever it is that they have, and their function can call their own version of date. And input and output is very important. No computer application is complete without taking some processing in, doing something with it, and then sending the processing results out. Now, we covered I/O a little bit in the intro class, but there's more to it. So we've got more than just C in and C out, which I'm sure you've seen plenty of times if you've ever seen any C++ code. So we will be looking at the class hierarchy for the various objects that make up the I/O system in C++. We'll take a look at the classes that provide which features, and we'll also turn on the exception handling. And rather than testing the I/O status bit each time, we'll let the functions themselves throw an exception. We'll just catch that. And we'll also use the string stream object. There's a string stream, there's an input string stream, and an output string stream. Now, all input and output in C++ consist of streams. They're either going in from a device or going out to a device. The string stream acts as an input-output device. So you can go out into a string stream, or you can pull data in from the same set string stream. And it allows you to take advantage of the parsing capabilities that are normally associated with C in and C out. So that gives you a lot of power in terms of setting the number of decimal places that you want to display or print or whatever else. And we'll talk about functions. Functions are very necessary for any type of programming. We talked about it in the introductory class. We'll talk about more things in this class. So We'll talk about adding parameters to the main function. You might not have thought of the main function as being a function, but it is a function, and it has parameters, and it has a return value that's captured by the OS. The main function is your function that's called by the operating system. And we'll talk about inline functions for those quick and dirty, troublesome calculations that you don't want to actually call a real function for. Like, for here's an example. We have an inline int square of an integer a that returns a multiplied by a. So rather than putting a star a in your code all over the place, you just call the square of the number. So you can have many things in there. You can make it very long. The compiler might turn it into a regular function if you make it too long. But for some of these types of calculations of this nature, the inline keyword saves you some hassle. We'll talk about recursive functions. Most modern languages handle recursion, and C++ does as well. We'll talk about that. We'll talk about passing pointers to a function. Now, we've already talked about pointers and arrays in the previous class. In this class, we'll talk about having a function being pointed to and then passing that to another program, and that program grabs that pointer and uses it to call your function. We've used that a little bit with creating sets and lists and vectors, because there's a sort function, there's a sort method on those particular containers. But if you've done an object, if you created your own object, the compiler doesn't necessarily know how to sort it. In order to know how to sort it, it has to know which object is less than the other object, how to determine that. So you write a less than function, or have a less than method, or overload the less than operator for that object, and you pass that into the vector or to the linked list, what have you. And then you can tell the linked list to sort it, and it will use that function and call the pointer. It'll dereference the pointer to your function to call your function in order to determine, does this object go before this one or the other way around? And that way it can sort the objects inside the container. So we'll also talk about how to dereference that function, the pointer to function. And we'll talk about some issues with passing a multi-dimensional array into a function as a functional parameter. And we'll talk about what the problems are and some ways of resolving those issues. And there's more types in C++ than what we covered. So we'll have little things like a union that forces memory overlap. Normally you want some memory here, some memory there, new memory there. You can use a union. You have, okay, this is my string variable, and these are my integer variables, and I want to put them right on top of each other in the same memory. And sometimes I want to access it as an integer. Other times when I want to access it, I want to access it as a string. Well, union lets you do that. It's not the best way to do it, but there are occasions when you need that type of feature, and we'll show you how to use that. We also have the enum type. So you don't want to have to remember the numbers. Okay, variable equals 0, variable equals 1, variable equals 2, variable equals 3, 4, 5. Just list them out. And it will automatically, for this particular flavor enum, will make this 0, 1, and 2. And you can add more and slip them in between. And as long as you, throughout the code, you always use the variable, everything will compile together, and chocolate will always be greater than vanilla. We'll talk about how setting up a type def. We create new types with that. We'll talk about some of the cautions with that, and particularly like the time t, which is really a type def to integer, but at some future point in time they might change it to something else, such as a 64-bit integer. And we'll talk about keeping things the same using the const keyword and allowing things to change with the immutable keyword. And of course we have the pre-compiler macros, or the preprocessor macros. You've used those already if you've done any code in C++ when you have your include. The include directive is a preprocessor macro. It goes out and includes the file. This is not a language feature. The C++ compiler does not go out and include the file. The preprocessor goes out and includes the file, and it includes it all in one big package, and then gives that to the C++ compiler. So we'll talk about how define works with that for setting up constants. We'll talk about when there's many of the macros that let you do a lot of fancy stuff, but there are a lot of cases you're better off using the C++ features that will do the same thing and are type safe. It won't allow you to do things with different types, like mixing pointers and integers, that could cause all kinds of dangerous things to happen in your application. But there are some cases where there is no C++ replacement, so you can go ahead and use the macro. We'll talk about all of that. In particular, you have the conditional compilation with an if-def. So you can use an if-def. If a certain macro has been defined, then you have some code. If that macro was not defined, that code does not exist. You can see it, but the compiler will not see it. And we'll write functions with macros, which is particularly dangerous. So it's almost always a bad idea in C++, but we'll talk about them specifically because when you go out and actually look at real code, people do use them that way. So you need to know how to at least recognize them. And there's some compiling. We will talk about actually compiling the code, and we'll add things like, I love adding the -d. So that will define a preprocessor macro. So when you have an if-def, if you compile it with the -d, that macro will be defined. You put -d testing, for example. So if in your code you've got if testing has been defined, then you'll have some code, and then end-if will end that section. So you can have testing code right there in your code, and just as long as you have the -d testing on your compilation, your testing code will get executed. When it's time to turn it over and hand it to the customer, you take that flag off, that code disappears, and then your code is totally clean of whatever your testing materials are. Now, your IDE usually hides that sort of stuff from you. but they are passed to the compiler in some kind of manner, depending on what IDE you're using. We will talk about how to get around that, how to use Eclipse to set that up so that different things like -D will get passed in. We'll talk about some other common flags like -C that will create an object file from the source, -O that creates an executable, -I, which allows you to find the include files that get included into the include directive. They're not necessarily in the same place, depending on what other applications you're using to grab the various different include files for the various different things that you're using. The -L define the libraries. The include files just define the prototype. The library will actually have the binaries that you have to use to actually run whatever the facilities are that are being provided for you. So that allows you to make your preprocessors by putting them on the command line. And -G is a good one, which allows you to get a real-time debugger. You can actually get something like GDB, where you can actually have your process is actually running, and you can run the GDB from the command line, tell it to connect into that processor, and as its process is running, you can actually set in breakpoints as if it ever reaches this line, stop. And when it stops, you can say, well, let me look at the contents of this variable. When you look at the contents of this variable, and say, oh, well, this variable's got a strange value. Let's go back and watch this variable. And every time the variable gets changed, the GDB will stop and say this variable has been changed, and you can look at it and find out why is your code doing something that it's not supposed to do. Well, you need the -G flag on your compiler in order to put in those hooks for the runtime debugger to catch into. Okay, tally ho! We're ready to get started. Now, the horse is saying, watch that sword, it's sharp. This is not C#. This is C++. Anyhow, I hope you enjoyed the class here at educator.com. I'll see you at the next lesson.